A silent telescope points at a sky full of secrets it can no longer tell. We are uncovering the stories of 20 abandoned observatories and what they saw before going quiet. You will learn the hidden reasons these places were shut down and the unsettling data they left behind. What was the complex signal from an empty void that made a researcher write, "It is not natural"? Why did a satellite declared dead send back a final warning about an object passing through our solar system? This journey reveals how close we have come to monumental discoveries, only to turn out the lights. What do you think is the greatest mystery we have walked away from? Deep in a secluded mountain valley, the massive white bowl of the Mount Lochnar radio dish once listened to the cosmos. It was officially decommissioned in the late 1980s, its funding withdrawn and its staff sent home. But the final weeks of its operation were anything but quiet. The facility began recording a powerful, repeating signal from a patch of space that star charts showed as a complete void. This was not the faint whisper of a distant quasar. It was a strong, deliberate pulse, designated by the overwhelmed staff as Lochnar Burst 7. The signal itself was the real mystery. It was not a simple blast of static. Analysis revealed a complex, layered structure that suggested an underlying mathematical order, a sequence of pulses that defied all known natural explanations. The small team of researchers stationed there was utterly baffled. Their logbooks, recovered years later by urban explorers, tell a story of growing obsession and unease. The lead astronomer's entries became more frantic, filled with notes on non-random patterns and harmonic intervals that seemed artificial. The final entry in that logbook is a single, handwritten sentence that has haunted the story ever since. It reads simply, "It is not natural." Soon after that note was written, the final funds were cut. The power was shut off, the gates were locked, and the giant dish was left to be slowly consumed by rust and ivy. The Lochnar Burst 7 was never officially investigated by any other facility. It remains one of the most compelling what-if stories in the annals of sky watching. A potential first contact that was literally turned off, leaving us to forever wonder what message was being sent and who or what was sending it. Perched on a windswept coastal cliff, the white dome of the Stella Maris optical station held one of the clearest views of the southern sky. Its mission was straightforward, a long-term survey of a seemingly ordinary star cluster. But in its final year, the data began to tell a different story. The stars themselves were blinking, not with the predictable rhythm of an orbiting planet, but with a strange, minute dimming that occurred at irregular intervals across several different suns. These were not the clean, symmetrical dips in light that signal a world passing in front of its star. They were jagged, complex shadows that seemed to shift and change. The lead researcher championed a radical theory. He proposed that the data was consistent with something far more profound than natural astronomy, the possibility of massive artificial structures, orbiting constructs so vast they could only be the work of an advanced intelligence. Imagine a network of solar collectors or habitats, so large they cast a detectable shadow from light years away. It was a hypothesis that could have rewritten our understanding of the cosmos. But the paper arguing this extraordinary claim never saw the light of day. Just as the analysis was nearing completion, the Institute lost its primary government grant. The funding was pulled, the team was disbanded, and the Stella Maris was shuttered for good. The final insult came later when a burst pipe flooded the station's basement archive. The original photographic plates, the only hard evidence of those anomalous shadows, were submerged. water warped the delicate emulsions and mold ate away at the star fields, corrupting the raw data beyond recovery. The strange dimmings were never officially verified by any other telescope. We are left only with the ghost of a theory, a haunting question mark hanging over a forgotten star cluster. What exactly was casting those shadows? The answer is now lost, washed away by a simple, tragic leak, a quiet demise for a potentially universe-shaking discovery. High in the thin, dry air of the Chilean Atacama Desert, the mirrors of the Zenith array once drank in the clearest starlight on Earth. This network of telescopes was pointed at a seemingly blank region of space, a dark nebula known as a molecular cloud, a place so thick with dust it blocks the light of any stars behind it. It should have been a portrait of perfect nothingness, but the array's final time-lapse footage told a different story. Deep within that absolute black, the core of the nebula began to flash. It was not a random sparkle of cosmic static. These were distinct, localized pulses of light, appearing in the same precise spot again and again, like a lone beacon switching on inside an impenetrable fog. The small team began to call it the Lighthouse effect. A junior astronomer poring over the data made a startling correlation. The intervals between these flashes were not random. They followed a complex, repeating sequence with a mathematical precision that no known natural phenomenon, like a variable star or a collapsing gas cloud, could possibly produce. It was as if they were looking at a timed signal, a piece of machinery or a structured emission operating on a fixed, intelligent schedule. But the political landscape on the ground was shifting violently. With funding lines cut and access to the remote site becoming unsafe, the Zenith array was abandoned in a hurry. That junior astronomer's report, which argued so compellingly for an anomalous source, was printed and placed on a desk, only to be left behind when the scientists evacuated. The site is now a collection of silent domes, their instruments slowly succumbing to the desert dust. The mystery of the lighthouse in the dark nebula remains, its perfect, inexplicable rhythm still ticking away in the void, waiting for an audience that is no longer there to see it. While the Zenith array watched a silent beacon flash, another facility recorded a cataclysm with no sound at all. The Etherius gamma-ray facility was built in an isolated high-altitude basin, a place designed to catch the universe's most violent tantrums. Gamma-ray bursts are normally the final screams of dying stars, cosmic explosions so powerful they outshine entire galaxies for a few fleeting moments. And they are never quiet. They come with a full orchestra of energy, a flash of visible light, a shriek of radio waves, a cascade of X-rays. But in its final days of operation, Etherius recorded something that broke all the rules. It was a silent burst. The instruments registered a massive spike in gamma-ray activity, an energy release that should have signaled a stellar death of unimaginable scale. Yet when other telescopes around the world were checked, they had seen nothing, no flash, no radio pulse, no accompanying signal of any kind across the entire electromagnetic spectrum. It was as if a bomb had gone off in a perfect vacuum, releasing a tremendous wave of invisible force but not a single photon of light. The facility's director immediately recognized the profound implications. This was not just a new kind of explosion, it was a challenge to the fundamental laws of high-energy physics. He filed an emergency petition, begging for a temporary funding extension to point every available instrument at that same patch of sky. He argued that they were witnessing a completely new class of cosmic event, one that operated by rules we do not yet understand. The request was denied. Budgets were being slashed, and newer, more sensitive facilities were coming online elsewhere. Etherius was deemed redundant, a relic of an older technological era. The site was abandoned, the power cut, and the data from that silent burst was boxed up and sent to a long-term storage archive. That unprecedented event, a cosmic cataclysm that defied every standard model, now sits on a forgotten server tape or a stack of printed paper in a warehouse. It is a universe-shaking discovery that was simply filed away, a ghost in the machine of science, waiting for someone to stumble upon it and ask the right questions about the nature of that invisible, silent fury. While the Etherius facility recorded a silent cataclysm, another abandoned site was listening to a sound that never stopped. The K-Vassia gravitational wave detector was an early, less sensitive cousin to the massive instruments we have today. Its design was simple, a set of long, evacuated tunnels with lasers meant to catch the faintest ripples in the fabric of spacetime itself. In its final months of operation, long after its scheduled shutdown date, the data logs revealed something peculiar. The instruments were not just picking up the expected chirps and bursts from distant black holes colliding. They registered a constant, low-frequency hum, a persistent vibration that seemed to permeate the very space around it. This cosmic background rumble was so subtle and so steady that the engineers initially wrote it off. They assumed it was just seismic noise, the grumbling of the Earth itself, a problem they could not filter out. The facility was soon closed for a planned upgrade, a renovation that was ultimately cancelled due to lack of interest and funding. The site was simply left as it was. Years later, a graduate student rediscovered the old K-Vassia data while researching her thesis. Her reanalysis was shocking. The hum was not random noise at all. Its frequency and stability were unlike any known geological activity. She proposed a radical idea that K-Vassia had been listening to a continuous source of gravitational waves. Think of the difference between hearing a single, loud crash in a quiet room and hearing the constant, low hum of a massive generator running in the basement. Our modern detectors are built to listen for those sudden crashes, the transient mergers of massive objects. But what if the universe is also filled with these steady, background generators, humming away just below our threshold of attention? The implications are staggering. This persistent signal could have been evidence of something massive and nearby, something constantly warping space. A rapidly spinning, slightly lumpy neutron star, a close-by pulsar we had somehow missed, or perhaps something even more exotic, like a cosmic string or a primordial phenomenon left over from the birth of the universe. We will never know for sure. The K-Vassia detector was abandoned, its upgrade never realized, and that steady whisper from the cosmos was left uninvestigated. It is a reminder that sometimes the most profound mysteries are not in the loud, explosive events, but in the quiet, constant signals we learn to ignore. For decades, the Helios solar monitoring station was a vigilant sentinel, its specialized telescopes providing an uninterrupted stream of data on our sun's every mood swing. Its final transmissions, however, captured something that defied all classification. It was not a solar flare or a coronal mass ejection, but a massive, slow-moving dark spot drifting across the sun's outer atmosphere. This was no ordinary sunspot. Sunspots are temporary, magnetically active regions that are anchored to the sun's surface, rotating with it. This feature, which the last technician on duty called the wandering shadow, moved independently. It traversed the searing plasma of the corona against the sun's own rotation, as if it were a vessel sailing against a current of fire. The high-resolution images revealed an internal structure that was bizarrely complex, a web of dark, filamentary tendrils that seemed to shift and writhe within the main body of the spot. The data suggested it was a coherent object, not just a random fluctuation in solar density. The station was already slated for a crucial hardware upgrade, a refresh that would have given it the sensitivity to analyze the shadow's composition. But in a familiar story, budget priorities shifted. The funding for the refresh was reallocated to a newer, more glamorous deep space project, and the Helios station was not just upgraded, it was completely shut down. Its telescopes were powered down for the last time just days after the wandering shadow was first noted. Other solar observatories around the world were never pointed at that specific coordinate in time. The phenomenon was never seen again. The official explanation filed away in a report was that it must have been a transient atmospheric effect or a strange instrumental artifact, a ghost in the machine of the aging observatory. Yet a handful of researchers who saw the original data still wonder. Could it have been something else entirely, a vast dark structure not of the sun, but simply passing in front of it? We are left with a handful of still images, a shadow that moved to its own rules, and the unsettling possibility that something visited our stellar neighborhood, was recorded by a single watchful eye, and then vanished back into the void the moment that eye was closed. Far from Earth on a desolate plateau, a different kind of watch was kept. The Salini lunar laser ranging base aimed not at distant stars but at our own moon. Its purpose was one of precision, firing powerful laser pulses at suitcase-sized retroreflector arrays left on the lunar surface by the Apollo astronauts. These arrays are essentially sophisticated mirrors, designed to bounce the light directly back to its source. By timing the laser's round trip, scientists could measure the distance between Earth and the Moon with an accuracy of a few millimeters. It was a steady, reliable process for decades, a quiet conversation with our closest celestial neighbor. Then, in its final year of operation, the conversation developed a stutter. The base began recording a series of anomalous returns. Laser pulses aimed at specific reflectors would sometimes come back significantly fainter, as if their light was being partially blocked or absorbed before it could make the journey home. The data was clear. Something was intermittently obstructing humanity's precise mirrors on the Moon. Internal memos from the time reveal a team grappling for an explanation. They coined a term for the phenomenon, transient obscurations. The leading theory was a natural one. Perhaps it was fine clouds of electrostatically charged lunar dust, kicked up by the constant peppering of micrometeorites and levitated just enough to hover over the reflectors. Or maybe it was subtle outgassing from the Moon's interior, releasing thin plumes of gas that would slightly distort the laser's path. These were plausible ideas, but they required confirmation. A dedicated observation campaign was proposed to monitor the reflectors continuously, to catch the obscuration in the act and analyze its properties. But that campaign never happened. The Salini base was decommissioned, a casualty of budget consolidation as newer, more glamorous space projects took priority. The lasers fell silent and the subtle clue was left unresolved. So what was temporarily blocking those mirrors? We are left with a quiet mystery on an airless world, a hint that the lunar surface may not be as static and predictable as it appears. It suggests an active, dynamic environment, one where invisible veils might still drift across the ancient dust, noticed only in the fading echo of a laser beam that no one is sending anymore. Deep within the silent, frozen expanse of the Arctic Circle, the Borealis Auroral Observatory was a lone outpost dedicated to the dance of the northern lights. Its final winter of operation gifted it with a sight that has since become legend among those who study the sky. While the aurora is normally a river of shimmering, shifting color, the observatory's instruments recorded something entirely different. A perfect luminous circle of deep green light hung motionless in the night. They called it the Auroral O. For over an hour, this geometric form defied the chaotic, flowing nature of every other aurora around it. a stable, unnatural-looking ring etched into the polar atmosphere. The data made the mystery even deeper. Solar wind activity was calm, and the standard atmospheric models that predict auroral displays could not account for this static, structured shape. The observatory spectrographs, which break light down into its constituent elements, added the final, baffling piece. The green light carried an unusual elemental signature, a combination of gases that did not match the typical high-altitude interactions. It was as if the ingredients for the light itself were alien. The following spring, the facility was shuttered. The official reason was the crushing cost of maintaining a presence in such a hostile environment. The official explanation for the O was a 1-in-a-million plasma instability, a freak event of nature. But that perfect circle, captured in a handful of photographs, refuses to be so easily dismissed. How does a swirling, chaotic phenomenon suddenly lock into a perfect, stable geometric form? What could possibly cause such a specific and prolonged emission of light from an unexpected recipe of elements? The Borealis Observatory closed its doors, leaving the Auroral O as a single, breathtaking data point, a question mark written in green fire across the Arctic sky. The rules of physics seemed to be rewritten in a nondescript laboratory buried deep underground. This was the Quantum Entanglement Laboratory, a place that abandoned telescopes entirely in favor of a far more radical instrument, the quantum link itself. The researchers were not looking at light from distant stars, they were trying to feel cosmic events through a ghostly connection. Their experiment relied on pairs of entangled particles, twins born from the same quantum event. According to the strange rules of quantum mechanics, whatever happens to one particle instantly affects its twin, no matter how far apart they are. The team was attempting to use this spooky connection as a sort of cosmic telegraph. They would keep one particle of each pair safe in the lab, while its twin was, in theory, sensitive to the immense energies of deep space. The goal was to see if a cataclysm in a distant galaxy, like a gamma-ray burst, could trigger a detectable change in the local, shielded particle, a signal that would travel faster than light itself. According to a set of leaked notes from a senior technician, it worked. The notes describe a specific day when their sensitive equipment registered a sudden, inexplicable quantum shift in a collection of local particles. Mere moments later, conventional telescopes around the world confirmed the arrival of a powerful gamma ray burst from a galaxy billions of light years away. The local particles had seemingly reacted to the distant cataclysm before the light from that explosion had even finished its journey across the universe. The implications were nothing short of earth-shattering. It suggested a way to peer across the cosmos instantaneously, breaking the ultimate speed limit set by light. But then silence fell. The project was not just shut down, it was erased. Funding was pulled without warning, all records were classified and sealed, and the entire team was disbanded under strict non-disclosure agreements. The building was simply abandoned, leaving behind only the ghost of an experiment. Was this a genuine breakthrough, a discovery so disruptive to our understanding of physics that it had to be suppressed? Or was it a sophisticated experimental error, a case of wishful thinking misinterpreted as reality? We are left with only those leaked notes and a profound question hanging in the air. Did we accidentally unlock the universe's fastest communication channel, only to immediately throw away the key? While the quantum lab searched for instant cosmic signals, another facility was listening for messages from a different kind of messenger, one that barely interacts with our world at all. The Oceanus abyssal neutrino detector was not a telescope in any traditional sense. It was a vast grid of sensitive photomultiplier tubes, suspended in the crushing blackness at the bottom of a deep ocean trench. Its location was chosen with care, using the immense pressure and darkness of the deep sea as a natural shield. It was designed to sense the faint flashes of light created when a nearly massless, ghost-like particle called a neutrino passed through the water and, on a very rare occasion, interacted with it. Neutrinos are cosmic phantoms, able to fly straight through planets and stars as if they were not even there. They are the perfect messengers from the most violent and obscured places in the universe, from the hearts of supernova to the violent accretion disks of black holes. But in its final months of operation, Oceanus heard a whisper that made no sense. It detected a faint but maddeningly consistent stream of neutrinos. They were not coming from a known supernova remnant or a brilliant quasar. They were arriving from a specific point in space that every other telescope, from radio dishes to gamma-ray observatories, confirmed was a complete void. This patch of sky was a cosmic desert, a place with no known stars, no galaxies, not even a hint of a distant black hole. Astronomers called it the ghost source. And it emitted nothing else, no light, no radio waves, no X-rays, just this silent, steady drizzle of the most elusive particles in the universe. Imagine standing in a completely dark, silent room and feeling a constant, gentle breeze on your face, a breeze coming from a solid brick wall. That was the paradox the Oceanus team faced. The existence of this source hinted at something revolutionary, a completely new class of dark object in the universe. Perhaps it was a vast cloud of dark matter, annihilating itself and producing neutrinos as its only byproduct. Or maybe it was a type of failed star or a primordial black hole, so dark and cold that it had no other emissions, yet still churned out these ghost particles from its core. The project was defunded before a coordinated follow-up observation with other neutrino detectors or powerful optical telescopes could be arranged. The deep-sea cables were cut, the lights on the sensor grid went out, and the Oceanus detector was left to the eternal darkness of the trench. The source of those ghostly neutrinos remains one of the ocean's deepest secrets, a steady signal from an impossible place, a reminder that the universe may be filled with dark, silent giants we have only just begun to sense. The night sky is supposed to follow predictable rules, a celestial ballet governed by gravity and momentum, but the Kronos Meteor tracking array watched a performer break every single one. This network of high-speed cameras scattered across a remote desert was built with one simple purpose: to watch for streaks of fire as space rocks burned up in our atmosphere. On its final night of full operation, it captured an event that defied all expectations. A meteor flared into view, a brilliant point of light screaming toward Earth at a perfectly normal speed. Then it began to slow down. This was not the gradual deceleration caused by atmospheric friction. It was a pronounced, deliberate reduction in velocity, as if a brake had been applied. The object then executed a gentle but undeniable turn, altering its trajectory by several degrees before continuing its descent. Finally, it did not explode in a violent fireball. Instead, it seemed to come apart in a structured, almost orderly fashion, dissolving into a cloud of glittering fragments. The analysis of that debris cloud was the most baffling part. The spectrographs, which read the chemical composition of the glowing gases, detected the clear signature of refined metals. These were not the rough, primordial alloys you would expect from a common asteroid. They were specific combinations, including elements like titanium and nickel impurities that suggested a technological, not a natural, origin. The official report, filed by the overseeing agency, dismissed the whole event with the bland label of an anomalous atmospheric breakup. It was a convenient term for something they could not explain, but the site manager's personal log, discovered much later, tells a different story. His final entry is a single, heavily underlined question. Was that a vehicle, the Kronos array was scheduled for a comprehensive technological upgrade, a refit that would have given it the resolution to potentially identify individual pieces of the debris. That funding never materialized. The project was shelved, the cameras were powered down, and the desert outposts were reclaimed by the sand. We are left with a single, inexplicable recording, a silent film of an object that entered our sky, changed its mind, and then dismantled itself with an intelligence that gravity alone cannot explain. High in the thin, rarefied air of the Andes, the Aura atmospheric probe station clung to a volcanic peak, its sensors perpetually tasting the winds at the edge of space. This remote outpost was not looking out but up, monitoring the chemical soup of our own planet's upper atmosphere. Its final transmission did not contain a dramatic signal from the stars but a chemical ghost. The instruments registered a sudden, intense spike of a complex organic molecule at an altitude of 50 miles, a region scientists call the mesosphere. This is a frigid, near-vacuum environment, a place where the very air is thin and simple. Such a complex carbon-based compound had no business existing there. It was like finding a fully formed snowflake in the heart of a blast furnace. The event lasted only 12 hours. The mysterious compound appeared, peaked, and then vanished completely, as if it had never been. The small team at the station was electrified. Two competing theories emerged. The first suggested a previously unknown form of high-altitude microbial life, tiny organisms somehow surviving and reproducing in that harsh frontier, a hidden layer of our own biosphere floating far above the clouds. The second, more speculative idea was that they had witnessed the final death throes of a piece of interstellar material, a comet or a grain of dust from another star system, which carried this unique organic signature and released it as it vaporized in our atmosphere. The only way to know for sure was to launch a dedicated sampling mission, to send a high-altitude balloon or a rocket through that exact patch of sky to capture the evidence. The proposal was written, the excitement was palpable, but the funding was denied. The Aura station was deemed non-essential, its budget reallocated. The power was cut and the probes fell silent, so we are left with a single, tantalizing data point. Did we almost discover life in our own sky? A secret ecosystem drifting high above our heads? Or did we record the chemical fingerprint of a visitor from another world, a message written in complex chemistry that faded before we could learn to read it? The answer evaporated with the wind, leaving only a question mark hanging in the thin mountain air. A dead satellite suddenly began to speak. The Echo Satellite Relay Outpost was a lonely ground station, a collection of rusting antennae tasked with listening to a network of early scientific probes. Most of those satellites had long since fallen silent, officially decommissioned and forgotten. But one of them, a probe declared dead for years, unexpectedly woke up. Its signal was faint and broken, arriving in short, automated bursts that the old outpost systems struggled to lock onto. It was the ghost of a machine whispering from the void. The technicians managed to capture fragments of the data stream, a collection of corrupted packets that hinted at something extraordinary. The satellite's long-dormant instruments were not just online, they were registering a massive gravitational anomaly. The partial data described an object of immense size and staggering density moving through the outer solar system, far beyond the orbit of Pluto. It was not a comet nor a known asteroid. The readings pointed to something far more substantial, a body with the gravitational pull of a world, yet emitting no light of its own. Think of a ship's buoy bobbing silently in a foggy ocean, suddenly tugged by the wake of an invisible aircraft carrier. That was this satellite, its dead sensors jolted to life by the passing of a hidden giant. The team worked frantically to clean up the signal, to get a clearer picture and, most importantly, a trajectory. Where was this dark wanderer headed? Had it already passed by, or was it still approaching? But the signal was too degraded, the data too fragmented. Every attempt to re-establish a stable link failed. The satellite's whisper faded back into the eternal radio silence from which it had come. Soon after, the outpost itself was deemed obsolete and shut down for good. The antennae were powered down and the doors were locked, so we are left with a haunting possibility, a single corrupted data point suggesting that a rogue planet or a dark star, a sunless world from the interstellar depths, may have drifted right through our solar system. It was a ghost detected by a ghost, a warning from a dead machine about a visitor that passed in the night, its path and purpose forever unknown. Our planet's magnetic field is a vast, invisible shield, a constant presence we rarely stop to consider. Deep within a shielded bunker, the Tellus Geomagnetic Anomaly Lab was dedicated to listening to its every whisper. For decades, its super-sensitive magnetometers charted the field's gentle, predictable waves, its slow dances with the solar wind. Then, in its final year of operation, the calm was broken by a series of stabs. The data charts did not show gentle curves. They showed sharp, vertical spikes, like needles jabbing into the graph paper. These events, which the staff called magnetic needles, were incredibly brief, each lasting only a few seconds. They were intensely localized, detected by the lab's instruments, but not by any other monitoring station just a few hundred miles away. The immediate search for a cause came up empty. There was no solar flare, no burst of cosmic rays, not even a minor earthquake to explain the sudden, violent twitching of the local magnetic field. It was as if something invisible was briefly puncturing the fabric of space right there, again and again. A visiting theoretical physicist fascinated by the data proposed a breathtaking explanation. He authored a controversial paper arguing that the needles were not a malfunction. He suggested they were the literal signatures of ultra-dense, exotic particles passing straight through the Earth. He pointed to theoretical candidates like nuclearites, hypothetical lumps of strange matter left over from the Big Bang, or other compact objects so dense they could slice through our planet like a bullet through smoke, their immense mass warping the local magnetic field for the briefest moment as they traveled. The idea was revolutionary. It meant that our world might be constantly peppered with fragments of the primordial universe, cosmic bullets we had never noticed because they only revealed themselves in these fleeting magnetic pinpricks. But the wider scientific community was deeply skeptical. The effect was too strange, too localized, and impossible for other labs to verify. The paper was dismissed as speculation, an attempt to explain a glitch with fantasy physics. With its primary research question leading to a dead end, funding for the Tellus lab quickly dried up. It was closed, its sensitive magnetometers powered down and packed away. The magnetic needles, a potential sign of the universe's most exotic matter interacting with our world, were forgotten. They remain a ghost in the machine, a hint that the most profound discoveries might not be in the distant cosmos, but in the invisible stabs we feel right beneath our feet. The sky above the Nimbus Cloud Physics Observatory was a brilliant, cloudless blue, a condition that made its final recording so utterly baffling. Perched on a remote tropical island, this facility was a sentinel for the most violent weather, its instruments finely tuned to the raw power of thunderstorms. But it was a single, lonely cloud that delivered the most extraordinary event in its history. This was not a massive storm system, just a small, isolated cumulus cloud floating in an otherwise serene sky. From this unassuming puff of white, a colossal spear of energy erupted upwards. This was a superbolt, a rare form of lightning known as a positive giant, carrying 100 times the raw power of a typical lightning strike. It did not lash down at the ocean below. Instead, it tore a path straight up into the atmosphere, a reverse lightning bolt aiming for the stars. Scientists call this a gigantic jet, a bridge of electrical fury connecting a storm cloud directly to the edge of space. The observatory's sensors were overloaded by the sheer energy of the upward strike. But in the chaotic data, a second, more subtle signal was found. At the precise moment the gigantic jet terminated in the ionosphere, a brief, powerful burst of radio waves was detected emanating from that same high-altitude point. It was a radio echo, a final whisper from the edge of space, as if the lightning had triggered something or opened a momentary door. The researchers had barely begun to analyze this one-of-a-kind data set when the island was hit by a ferocious hurricane the very next season. The Nimbus Observatory, built to study atmospheric violence, was utterly demolished by it. The facility was never rebuilt. The pristine data recorder and its backups were lost to the storm surge, leaving only the initial instrument readings that had been transmitted off-island. That single upward lightning bolt from a clear sky and its mysterious radio echo remain a complete anomaly, a fleeting glimpse of an atmospheric phenomenon we have never seen again. What did that gigantic jet truly connect to, and what was the source of that answering radio call from the void? The storm that erased the observatory ensured we may never know. The Sun's outer atmosphere is a seething ocean of incandescent plasma, a place of unimaginable violence and beauty. The Solis coronagraph outpost was our window into that chaotic realm, using a special instrument to block the Sun's blinding face so we could study the delicate, wispy corona surrounding it. Its final transmission, however, was not a portrait of serenity. It captured a wave, a true tsunami of energy rippling through the Sun's outermost layers. This was not a gentle swell. The data showed a distortion racing across the corona at millions of miles per hour, a speed that physicists argued was simply impossible. A plasma wave moving that fast should tear itself apart, its energy dissipating long before it could cross such a vast distance. Yet there it was, a massive, coherent wall of force defying every established model of solar behavior. The mystery only deepened when a separate, nearly forgotten dataset was unearthed years later. A radio telescope, also on the verge of being shut down, had recorded a brief, sharp burst of radio noise from deep space just moments before the coronal tsunami began. The timing was too perfect to be a coincidence. It seemed as if a distant, energetic event, a shockwave from some unseen cosmic cataclysm, had traveled across the void and literally slapped the Sun, sending a ripple across its face. But the two facilities were operated by different agencies, their teams already packing their offices. The data was never officially brought together or analyzed by a single, coordinated group. The Solis outpost was closed, its unique coronagraph dismantled. We are left with a broken chain of evidence, a cosmic crime scene with two vital clues that were never compared side by side. Did a stellar explosion light years away actually cause a ripple on our own Sun? The possibility hangs in the air, a tantalizing hint that our star is not an island, but a participant in a galactic conversation we are only just beginning to overhear. Within the sterile confines of the Vortex Plasma Instability Laboratory, scientists were not observing the cosmos but trying to create a tiny piece of it. Their device was a magnetic bottle, a complex web of electromagnetic fields designed to contain a swirling, superheated ball of plasma, a miniature star right here on Earth. The final experiment was meant to push the system to its absolute limits, to see just how much energy the magnetic constraints could hold. For a fleeting moment, they succeeded too well. The containment field did not just fail, it ruptured. The subsequent sensor readings were a chaotic mess of overloads and emergency shutdowns, but buried in that digital noise was a single, impossible spike. It was a momentary resonance, a specific and bizarre energy signature that lasted for mere picoseconds. When a junior researcher finally cleaned up the data months later, he found it matched a purely theoretical profile, one found only in the most speculative physics papers. The reading was a perfect, fleeting fingerprint for a microscopic wormhole, an Einstein-Rosen bridge. Think of it as a tiny, spontaneous stitch in the fabric of space-time, a shortcut through reality itself that appeared and vanished in less time than it takes for light to cross the width of a human hair. The official report was quick and dismissive. It was labeled a sensor ghost, an instrument error caused by the violent electromagnetic pulse of the containment breach. The laboratory itself was declared too expensive and too hazardous to operate, its doors sealed for good, yet that one data point remains tucked away in a digital archive. It is the potential proof that we did not just observe a cosmic phenomenon, but accidentally engineered one in a lab. We created a keyhole to another place or time, saw it flicker into existence, and then immediately dismissed it as a malfunction, locking the door on a discovery that could have redefined our place in the universe. That dim red dwarf star was supposed to be a quiet neighbor, a solitary ember in the vast dark. The Gaia Astrometric Field Station had one job: to map the precise positions and movements of countless stars, and this particular star, catalogued as GF732, was just one faint point of light among millions. Yet its data told a story of profound disturbance. The star had a gentle, rhythmic wobble, a telltale sign that a planet was tugging on it as it orbited. This was not a massive gas giant. The calculations pointed to a world roughly the size of Earth, and it was orbiting squarely within the star's habitable zone, that Goldilocks region where temperatures could allow for liquid water to exist on its surface. It was the kind of discovery that fuels dreams, a potentially rocky world circling a star not so different from our own sun, a place where the conditions for life might just be right. But the data contained a second, more perplexing clue. Superimposed over that clean, rhythmic wobble were tiny, erratic jumps in the star's position. It was as if, along with the gentle, predictable pull of a single planet, the star was also being sporadically nudged by other, unseen forces. The pattern was chaotic, like a dancer being occasionally jostled by invisible partners on a crowded floor. Was this a complex solar system with multiple planets in a chaotic orbital resonance, their combined gravity creating this messy signature, or was it something else entirely? Perhaps a dense asteroid belt, a recent planetary collision, or even a swarm of artificial objects, their collective mass creating these unpredictable tugs on their host star. The mystery was on the verge of being solved. The station only needed more time, a long-term monitoring campaign to untangle the gravitational knots and reveal the true architecture of this nearby solar system. But the funding for the Gaia station was not renewed. Its mission ended abruptly, its precise telescopes falling silent. The site was abandoned, and the star, with its strange, jittery dance, was relegated to a forgotten entry in an old database. It remains out there, a silent question mark, a potential twin to our own world orbiting a star that can't seem to sit still. Its full story waiting for someone to point a modern telescope in its direction and finally listen to the rest of its gravitational song. While other observatories watched stars and galaxies, the Cassandra unit searched for the chemistry of alien worlds. This specialized facility was an exoplanet detective, using a powerful spectrograph to break apart the faint light filtering through distant planetary atmospheres. By reading the unique chemical fingerprints imprinted on that light, it could identify the gases swirling in the alien air of worlds trillions of miles away. On its final night of perfectly clear weather, the team pointed its eye at a well-known gas giant, a hot Jupiter locked in a close, fiery orbit around its star. The initial data was exactly as expected, showing the strong signatures of water vapor and methane. But buried within those familiar patterns was something impossible, a faint, recurring spike in the data that the software could not identify. It was a single, sharp absorption line at a wavelength that matched nothing in any scientific database on Earth. They called it the Cassandra line. The mystery only deepened when they tracked it over time. This unknown signal was not constant. It appeared and disappeared with the precise, regular rhythm of the planet's own rotation, blinking into view only when a specific region of the alien world spun into sight from our perspective. It was as if a single, enormous geyser was periodically erupting on that distant gas giant, venting a gas unknown to science into its stratosphere. Or perhaps it was the signature of a complex chemical reaction happening only in that one location, a permanent, planet-sized storm brewing a compound we have never conceived of. The discovery demanded a second look, a follow-up observation to confirm the line was real and not some fleeting instrument glitch, but that confirmation never came. The Cassandra unit was deemed surplus. Before the next observing cycle could even begin, it was scheduled for dismantling, its valuable optical components carefully removed to be used as spare parts for a newer, more general-purpose telescope. The project was cannibalized for progress elsewhere, so the Cassandra line remains an unverified specter in an old data set, a single, tantalizing clue. Was it the signature of an exotic form of matter, a crystal or a gas that forms under conditions impossible to replicate on Earth? Or was it evidence of a dynamic, localized atmospheric phenomenon on a scale we can barely imagine? It is a chemical question mark hanging in the void, a potential first glimpse of an entirely new branch of chemistry, discovered and then immediately lost when the one instrument that could see it was taken apart for scraps. The sprawling Ouroboros Deep Space Monitoring Complex was our most advanced sentinel, a place where every way of seeing the cosmos was brought together under one roof. Its final mission was a coordinated hunt, a 72-hour deep stare into a region of space that other, now silent, observatories had flagged as strange. The complex pointed everything it had at that coordinate, its optical telescopes, its radio dishes, its gravitational wave detectors, all working in unison. What they recorded was not an anomaly but an absence. For 3 full days, every instrument registered a profound and unnerving silence. This patch of space was a perfect void in the data. It emitted no light, no radio waves, no gravitational ripples. It was as if they were staring at a hole in the universe, a place that absorbed every signal and gave nothing back. Then, the moment the official observation window closed and the systems began to power down, a single, coherent radio pulse arrived. It came from the precise mathematical center of that absolute silence, a perfect shot from the heart of the void. The pulse was brief, but its content was staggering. It contained a seemingly random sequence of prime numbers. These are the fundamental building blocks of mathematics, numbers divisible only by themselves and one, often considered a universal language, a potential signature of intelligence. The Ouroboros complex had spent days listening to nothing, only to receive a mathematical echo from the emptiness itself. 1 week later, a global funding crisis led to the facility's immediate and permanent decommissioning. The complex was shuttered, its synchronized instruments falling silent forever. The silent void and its prime number response stand as the ultimate cosmic riddle from that era. Was it a final hello, a signature left by something we cannot comprehend? Or was it the universe's most sophisticated prank, a mathematical whisper from the dark that we were never meant to understand. These 20 stories of silence are not just random tragedies. They form a disturbing pattern, a collective whisper about the fragile nature of discovery itself. Time and again, these observatories became the sole witnesses to events that shattered the accepted models of their day. They saw signals with mathematical order, objects moving against cosmic currents, and cataclysms that broke the known laws of physics. Yet, in almost every case, the reason for their closure had nothing to do with the science. The plug was pulled for the most mundane of reasons: budget cuts, shifting political priorities, or simply because a newer, shinier facility was being built elsewhere. We prioritized progress over patience, and in doing so, we may have thrown away the keys to the universe's greatest secrets. How many genuine breakthroughs now sit in dusty storage rooms or on corrupted tapes, not because the evidence was weak, but because the funding ran out? The relentless pursuit of the new and the efficient often comes at a hidden cost: the abandonment of the anomalous and the inexplicable. These 20 sites stand as a silent monument to a difficult truth. Our quest for knowledge is not a straight line. It is a flickering candle in the wind, easily extinguished by the simple, practical concerns of the world. And when that light goes out, the darkness does not just return. It reclaims mysteries we may never get a second chance to solve.